The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna, for introducing the session. A very good day to everyone, and thank you for joining. Welcome to AI for Good's AI and Machine Learning Challenge webinar session. My name is Jiaying Meng from ITU, the International Telecommunication Union. The Machine Learning in 5G Challenge aims to create a community to solve various society problems using artificial intelligence or machine learning. Today, we're excited to host another interesting talk titled AIntuition, Unlocking Efficiency for Public Sector with Retrieval Augmented Generation Applications. This webinar aims to shed light on the role of retrieval augmented generation in transforming public administration, exploring its potential use cases, and discussing the challenge and opportunities for its adoption. As always, we are counting on you to help create an engaging discussion. If you have any questions, please type them on the video wall, and we will take them during the Q&A session right after the talk. Before officially kicking off the session, I would like to introduce our esteemed speakers, Dr. David Mansett and Roman Chesnoff. Dr. David Mansett, a senior project coordinator of the EC-funded OSCE project, which stands for Open Source Ecosystem Enablement for Public Services Innovation at United Nations, ITU. Our second speaker will be Roman Chesnoff, who works with the Digital Services Division of the ITU Telecommunication Development Sector on innovative applications of digital technologies and digital public goods. And finally, my dear colleague Vishnu, who will be taking charge of the Q&A session. Without further ado, I would like to pass the baton to Dr. David Mansett. David, the floor is yours.
Thank you, Jiaying, for this introduction. I would like to ask my colleague Roman to share his screen for displaying a few slides. I'm very happy to be here today and to co-present this AIntuition Hackathon Challenge introduction. So this work is presented as part of the ITU Open Source Program Office's developments. ITU has recently launched the creation of its own open source program office with the co-funding and thanks to this contribution from the Tides Foundation. So today we're going to discuss the challenge so-called AIntuition that aims to encourage the work and create a community around the retrieval augmented generation of artificial intelligences for public services administration tasks. Next slide, Roman, please. So as you know, and as is expected, artificial intelligence is expected to make a significant contribution to the sustainable development goal attainment. And we are, since a couple of months, working on the analysis and study of how to harness artificial intelligence technologies to enhance the efficiency of the public sector to deliver better services to citizens. AI is expected to play a crucial and critical role in advancing the SDGs. And with this challenge, we are looking to trigger and ignite a nice open source community around an interesting challenge that we will disclose the details of in the coming couple of slides. Next slide, Roman, please. So, as you all know of, the AI landscape is pretty broad. There are loads of implementations, open source stacks that are available to date, from autonomous systems, machine learning, deep learning, neural networks, pattern recognition, to natural languages, chatbots, and so on. On the other side, we can witness a surge in a number of developments that have started to take place in public administrations, in public services, ranging from intelligence, law enforcement and defense, healthcare and humanitarian response, public administration, agriculture, or even climate and energy. Some of which you can find, for instance, on the Digital Public Goods Alliance website, which has created a registry that's now referencing all of these AI-based, but not only all of the public services ongoing developments. So there are loads of potential use cases of interest in the public service, in the public sector, that are potentially benefiting from AI developments. But it's very difficult to pick up the right open source stacks and to get started with these developments for countries that are not already engaged into this competition. And this is part of the rationale behind this challenge, the AIntuition challenge. We want to help the countries better understand the potential of artificial intelligence and help them pick up the right open source software stacks to get started with developing basic public administration services using open source and open resources. Next slide, Roman, please. So we've been focusing for the last couple of months on the artificial intelligence developments in the public sector by running through a number of webinars that we thankfully could do thanks to the help of AI for Good. So we've been organizing a first webinar in January on open source artificial intelligence for public services innovation at large, where we could discuss the issues and challenges governments were facing with taking over open source developments of this nature. We've run through another iteration of this webinar series last March in digging further into education-related services to understand what were the potential use cases that would pioneer, that could benefit from artificial intelligence. Now with this and a number of other meetings, we've gathered, collected, analyzed, and understood a number of requirements for the countries to take over artificial intelligence and to come up with interesting developments. And we are preparing for end of May a nice workshop with countries to discuss the possibilities of using open source artificial intelligence for their public services. This workshop will take place on the 31st of May, and to illustrate and facilitate the discussion, we aim to come up with an interesting prototype implementation of artificial intelligence for public services and administration. And this is the point for this webinar and the challenge AIntuition that we are launching today. We want to create a community. We want you to help us come up with a nice prototype implementation for basic public administration use cases that could be further used by the governments, but also that will help them understand the potential of using artificial intelligences. Next slide, please. So with this, I would like to leave the floor to my colleague Roman Chesnov, who will talk about our choices in terms of open source, the criteria for this, and what it is that we want to achieve, technically speaking, in developing this open source artificial intelligence for public services and administration. Roman, the floor is yours.
Thank you very much, David. As an intro to the explanation of why this challenge and what are its objectives, I would like to highlight why the emphasis on open source. So there are several reasons for why public institutions might need open source solutions when it comes to implementing artificial intelligence enabled and RAG enabled applications. One obvious reason that comes to mind is, of course, the one that relates to security and privacy of data. Public institutions in countries are typically the custodians of an important amount of information that relates to citizen services, that relates to public administration. So very often there are rather strict regulations in place that require these institutions to be really selective in terms of the access that they provide to that data. And so having solutions that are fully open source and that public institutions can run locally on their servers without reliance on any external APIs allows to basically satisfy that criterion of security and privacy. Another very important reason for the focus on open source is the cost and administration. With limited resources that public institutions typically have, and all the budgetary restrictions that are placed on them by the annual or the quarterly budget plans, sometimes it's difficult to find the resources that are required to deploy commercial types of solutions that typically have quite restrictive pricing models, particularly when we consider the context of developing countries. Another important consideration for why open source is the performance. Actually, there has recently been a trend in the emergence of new open source models and solutions that actually outperform the ones that are offered commercially. So sometimes for specific use cases in particular, countries and institutions might actually want to go with open source solutions and models because those tend to perform better. Then, of course, once an open source solution is implemented, the institutions or entities that implement them, they have fuller control over the different parameters and hyperparameters that can be adjusted to their needs. And this also adds to transparency of what actually goes into these open source stacks and how the information is getting processed there. So stakeholders who go with open source solutions, they typically have greater control of what happens inside the black box, so to say. There's, of course, also the aspect of ethics and standards with some open source models extensively documenting what goes into the training and what safeguards and measures have been taken to ensure the respect for ethics and other standards that apply. Whereas with commercial solutions, typically this is not the case. And of course, another important thing when it comes to open source is the fact that it is really conducive to collaboration and knowledge exchange, which, of course, as ITU, we do want to promote as much as possible. Just a couple of examples to support the points that I made earlier. So when it comes to performance, you can see here a snapshot of the massive text embedding leaderboard from the hacking phase. And you can see there at rank 11, there is an open source model that actually outperforms the commercial model that is used by OpenAI, which you see on rank 13. The text embedding 3 large. And similarly, researchers have done analysis of cost and the price of running commercial models versus the open models. And in one instance, they found out that actually having an open source free model allows to save up to 30 times. So you pay 30 times less than you would with a commercial solution when going with an open source, which obviously is a big advantage. Now, David mentioned that the challenge is going to focus on the process which is called Retrieval Augmented Generation. And when it comes to deciding what type of a system to deploy in the context of public sector, there are really two options. There is the fine-tuning, and then there's the Retrieval Augmented Generation. And there are a number of reasons for why one would prefer to go with the Retrieval Augmented Generation rather than fine-tuning solution. So as you can see on the graph here, Retrieval Augmented Generation is actually requires a little bit less resources than fine-tuning does. Whereas it can achieve a comparable result in terms of the degree of contextualization that could be achieved. And another important reason is that once you fine-tune the model or once you train the model, the knowledge that you put into it remains static. So it doesn't change. There's no way to update that knowledge dynamically unless you go through another round of fine-tuning or training, which tends to be expensive and resource intensive. Whereas with RAG, you can actually have a system where you have a repository of knowledge or data that is dynamically updated, and you don't need to basically invest in retraining the model or refine-tuning it, which saves time and adds to efficiency. But more about this later. So that's where we come to the challenge, which we are very happy to run in partnership with AI for Good and Zindi. And I want just in a couple of words explain a little bit better why did we choose this particular focus for the challenge. So as I mentioned before, public institutions are typically the main owners of data in countries. They collect and process a lot of information, and that information can be leveraged to basically achieve many good things: improve efficiency, provide better services, proactive services, for example, conduct real-time analytics. Basically, there are many use cases for that data. However, most of the time, especially in developing countries, this data tends to be unstructured, and there are a lot of bureaucratic restrictions that limit the usability of all the data that these institutions accumulate. And in that type of a situation, retrieval augmented generation applications could actually serve as a tool to interact with this data more efficiently and use it to power different types of applications that can really meaningfully change the quality of services that is being that are being delivered to the population. So here, as you can see, are just a couple of broad examples of use cases, ranging from chatbots to robotic process automation, real-time analytics as well that I mentioned before. But one thing that really unites them is that in case of each of these use cases, the foundation is really the data that institutions have, which I guess is the case with all AI solutions. So we do really want to try and make sure that public sector institutions, ministries, governmental agencies, they have the right tools in place that they can seamlessly deploy and test to interact with the data that they have and leverage it to achieve something good. So what is a retrieval augmented generation? Basically, it is a process that allows a large language model to interact with a library of documents or data that is specific to a particular context or a particular institution. And the way this process works is you simply add the retrieval to the already well-familiar process of query and response that I'm pretty sure everybody had the chance to experiment with as part of all the chatbots that became available recently. The idea is that once an institution is able to curate a library of documents that it wishes the generative part of the system or the LLM to have access to, it provides it through a RAG pipeline to the generative model to provide contextualized responses to the queries that users make. And the first step in this process is called chunking, which refers to the process of decomposing these larger documents that institutions have in their databases into smaller chunks of text or data that are then embedded in a vector store through a vector embedding process. This vector embedding process involves the use of an embedding model, which is technically similar to an LLM, with the only difference that it sort of does the process in the reverse. And the output of that process are vector embeddings, which are numerical representations of the semantic meaning of words, sentences, or paragraphs that are then stored in a vector database. And the vector database is used to optimize search for relevant bits and pieces of information when they are being retrieved in response to a user query. So when user inputs his or her question, that question also gets embedded and converted into a vector, which is then compared to all the vectors that are stored in the vector database. And this process is called a similarity search, which essentially relies on linear algebra and allows to retrieve vectors or bits of information that are most semantically similar to the query that the user has made. And once this process is completed, ideally, the RAG system would retrieve top K, top 3, top 5, top 10 most relevant chunks of information that are then appended to the user query and are passed along with it to the generative module, the LLM, that then intakes that context, and generates a response. So in a nutshell, this is a very convenient and a relatively simple process to empower a chatbot or a large language model to interact with your data and provide responses that are based on your data. Now, although I did say that it is simple, it is actually not. So there are different challenges that are associated with this retrieval augmented generation process, and that require quite a bit of thinking and fine-tuning. So what do we need to improve in this entire system? Our objective is to make sure that in the context of public sector applications, these RAG systems, they retrieve highly accurate bits of information from the right documents, and they do not hallucinate. So they don't provide any information that is inaccurate or non-existent, particularly because in the context of the public sector, this can have significant implications. We do not want a chatbot deployed by the Ministry of Health to provide inaccurate or misleading responses to the population or a citizen who might be seeking some guidance or advice on a healthcare service that he or she might want to access. Right. So the challenge is to ensure that these RAG systems are highly accurate, precise, and reliable. One of the challenges that arises from dealing with the public sector documentation, which would serve as the basis for providing context to these types of applications, is that this documentation tends to be slightly different from the information that we would find openly in the internet. Public sector documents tend to use bureaucratized language. They tend to have a particular structure. And so far, there have been, at least to our knowledge, not that many open source solutions that account for these aspects that are really tailored to public sector use cases. And this is what we want to change with the help of this competition. So what are the components that could be improved in this entire process? The starting step, can actually be the query pre-processing, but let me start with what I have here on the slide, which is chunking. So how do you, in that kind of system, how do you chunk your documents? Do you use big chunks? Do you use small chunks? Do you chunk by paragraph? The method chosen will have implications on the accuracy of the responses provided by the RAG pipeline. In this particular example that you see on the screen, we have a copy of Article 11 from the WHO Framework Convention on Tobacco Control, which is a good representative kind of example of the type of legislative documents that you would have in countries and internationally. And you can see here that the way the article is structured sort of implies that it might be a good way to chunk it by paragraph. But in reality, the problem is that some paragraphs contain references to other paragraphs or subsections of the article. And in the event when a user asks a query that is related to one section or one subsection of that article, which has a reference to another section, typically what happens is just one section gets retrieved. And the other section that is also relevant to the user query that is mentioned in the retrieved chunk gets omitted because it's not semantically similar or not as semantically similar as the one retrieved to the user query. One could increase the size of the chunks and perhaps each article should be a separate chunk in this particular case. But this also introduces a lot of noise. Because if, for example, a user query relates to a specific provision within that article, let's say the packaging and labeling, the warning messages in particular, right? There is just section 1 and section 2 which talk about it, whereas section 3 and 4 are sort of less relevant to that particular query. So perhaps chunking by article is also not optimal, especially considering that the context window of the LLMs, which then intake the top K retrieved results, is typically limited. So in the event when you want to make sure that you include all relevant chunks of information, you don't want to take up the space with the bits of content that are not relevant to the user query. So that's one of the things that needs improvement, the chunking strategy. Another thing is what type of embedding model do you actually use to convert these chunks of content into vectors? And the type of model that is being used actually has implications for the retrieval process. In this particular example that you see on your screens, we ran a small test for 2 different open source embedding models, and the results were quite interesting. So in public sector or bureaucratic documents, term deliverables has quite special meaning. We use it to refer to the outcomes or the impact of the projects that our institutions engage in and implement. And so in the context of UN documentation, for example, deliverables as a term tends to have a special semantic relation to terms project and report. However, these 2 open source models, which seem to be fine-tuned on normal data, normal sample of data, which is not public sector specific, as you can see, they do not necessarily capture this semantic similarity, which we do want to emphasize in the context of public sector documentation. So the top 3 results based on the similarity search performed between the term deliverables and other terms that you see on the screen shows that actually only one of these terms was found to have a good semantic similarity in the case of one model, and the second model failed to capture the semantic similarity between deliverables, the term deliverables, and the term project and report. In fact, the term, the semantic similarity between deliverables and report has not been captured by neither of the models, which shows that there is actually, there might be a need for fine-tuning some of these embedding models on public sector data to be able to account for these different meanings that words and terms might have in public sector documentation and day-to-day language. So another component of the RAG system that requires thinking and work to optimize RAG applications for public institutions. What are the other components? There is query preprocessing, which perhaps should have been the starting point, actually. So imagine a user inputs the type of query that you see here on the screen. How do I get an approval for a publication? Which normally is the case for public institutions. When you publish a report or some other kind of outward-facing public document, you do need to seek approval. So how do I get one? Let's imagine that some civil servant is asking a ministerial chatbot on some guidance on that matter. So the relevant chunk that the Retrieval Augmented Generation application might retrieve based on semantic similarity is the following. To obtain an approval for a publication, follow the procedure described in the guidelines for planning future publications and events. Yes, this is relevant, and to an extent this is useful, but it fails to provide further information that is described in those guidelines, right? It stops at that point, probably because these guidelines are an annex to a document or a whole separate document altogether. So one strategy to mitigate this issue would be introducing some additional queries based on the original user query to try and get this extra bits of information from the library of documents that you have. So in this example, some potential subqueries or additional queries that could be generated by an LLM to accompany the original user query could be, how does the publication approval process actually works in my department? What is the first step to initiate a publication approval? What documents should I submit to get my publication approved? And these more specific questions most likely will trigger the search in the guidelines themselves rather than, the other part of the document from which the initial relevant chunk was retrieved. So perhaps there are other query preprocessing strategies that could be applied to optimize RAG output. Additionally, there could be an option of introducing multi-agent or multi-modal workflows where, for example, you have a user query, you run it through the standard RAG process where you conduct a similarity search over a vector store to retrieve the top K results. And then you have a separate LLM or an agent which is tasked with assessing how relevant these top K results actually are to user query. So sort of a step back, an additional component of the model that tries to improve or introduce that layer of quality control. And that agent, that LLM, does its thinking given the top K results and the user query, and then decides, does it need to retrieve additional information? And if it does, maybe it, reinitiates the retrieval process. And if not, if the top K results seem to respond well to the user query, maybe it can be then passed on to the generative unit to actually output the result. Just a few words about the evaluation evaluation process that we will be using for this challenge. We would be looking for solutions that will be essentially returning the most complete, the most accurate, the most precise results when it comes to retrieval. For the purposes of this challenge, as described on the Zindi webpage, we're not considering the generative part of the RAG pipeline, just the retrieval component. And when it comes to the quality of retrieved content, it will be assessed for completeness, precision, and noise. For completeness, basically what we will be looking at is how many of the most relevant bits of information from the provided documents actually get retrieved. And this is perhaps the most important measure in this assessment framework because it will also influence to an extent the precision and the noise. For the precision, we will be just conducting some comparison between the set of retrieved results and the set of ground truth available from the documents to see how they basically rank. So do the top K results retrieved by your solutions correspond to the top ground truth that are available from the documents? Does the top sort of the most important chunk of information in the ground truth corresponds to the most to the chunk that is assigned the highest similarity score in your top retrieved results, or is it ranked somewhere else? So this would be the essence of the precision, and the Kendall style would be used as a measure. And for noise, we just want to see how out of the content that gets retrieved, how much of it is the exact pieces of information from the documents that we are looking for, and how much of it is other relevant information that gets pulled along with these most relevant bits. In addition to the quality, which I just described, there will be the efficiency metric and the accompanying documentation. The idea for why these two criteria were introduced is because, as was mentioned by David and myself in the beginning, the whole objective of this is to produce an open source, fully localizable package of software that could be easily installed and used by non-technical people in public institutions in developing countries. And in that context, of course, we do want these systems to be efficient, lightweight as possible, and basically to be able to run them on ordinary equipment rather than something very special, very expensive. And accompanying documentation, of course, also would be an important factor, because we do want to provide the necessary explanation and guidance to the potential users in these public sector entities on how to install, deploy, and run these types of software. So I believe that, in a nutshell, concludes the hackathon or the challenge, the community challenge details, and I'm happy to pass the stage back to David. Thank you very much.
Thank you, Roman. Thank you for this exhaustive explanation on the technicalities of the challenge. I would suggest that we move forward quickly just to have sufficient time for questions and answers. So if you could move to this next slide just to conclude with, to say that this challenge will be motivated, of course, by a prize given to the best competitors, to the best contributors to these developments, and the results of which will be announced during the AI Global Summit, and in particular our workshop on the 31st of May, that will take place the whole morning. So we'll give the floor to the actual winners to have a chance to present their very exciting developments to the community, to countries, to actual doers that are interested in taking over artificial intelligences. So it's a great stage for highlighting and shedding light on your contributions and developments. So you're really welcome to help us with these developments, as we strongly believe that retrieval augmented generation is the right approach to help countries with scarce resources to take over artificial intelligences and have them trained over specific contents for their basic public administration needs, such as chatbots, but also process automation and so on. So please feel free to ask any questions, and be assured that we'll be rewarding these developments and taking them forward with a prototype that will try and turn into a minimal value product for our training program to countries. So with this, I would like to pass the floor to Vishnu for the questions and answers session. Thank you.
Thank you very much. That was very exciting challenge. Thank you so much. I want to ask, maybe there are a couple of questions in the chat. Let's start with that. How is the approach connecting to public health and public good? Maybe let me illustrate this a little bit. I think the question on specific domains such as public health and public good, the specific domains, how and what is the challenge participants' role in connecting that, or what is the approach that you guys follow in connecting such specific domains to the challenge? Can you please explain the role of the specific domains such as health or public good or other services, please?
Roman, do you want to address the question, or shall I take over?
Sure, I can start. I think when it comes to public documentation, of course, it's going to be to an extent different depending on which sector we're talking about. Health sector is a particularly complex one, and also a very sensitive one, because everything that is health related tends to have important regulatory and other implications. But nonetheless, public documentation across the whole range of sectors tends to have some features in common in terms of how documents are structured, the type of language they used. And when I speak about language, I do not refer to sector-specific languages like, agriculture has obviously its special terms, so does health, so does education. But then, the example that we saw before, the term deliverables, tends to be used in any document that describes, has to do with reporting or has to do with projects. So it's really cross-cutting, and it would be, we do not want to fine-tune or to tailor this solution to any specific sector. We want to make it as generic as possible to be applied across all domains within the public sector space, so to say. But as far as the public health is concerned, in particular, We also do want to provide our stakeholders with tools to be able to train or to fine-tune the RAG application on the specific use case that they might have. But this is a step that will come in the future. I'm not sure if it would be right to dive in it too deep right now.
Thank you so much. Yeah, I think that kind of answers the question. I think your point about vocabulary, the point about semantics that you mentioned in your presentation, and what I call as ontology, that there is how the terms are used in which context. This is kind of connecting the domains to the challenge. I want to ask you one additional question here. What is the input to the participant? I mean, what do you provide as input to the participant? Is there a base language model that you provide? Or is there a specific domain vocabularies or dictionaries that you refer to? Or is there some other data set or reference data set or something like that? So what is the input to the participant? What should the participant start running with, if you will, please?
Yes, a very important question indeed. Actually, the beauty of open source is that we have a lot of open source solutions already available. I mean, the baseline solutions and the embedding models and the LLMs that could be used. In the challenge description on the Zindi webpage, we actually included some pointers to different resources that participants can leverage to find these open source tools, and then they can kit bash them in any way they deem appropriate, as long as it satisfies the requirements of the competition. But so far there is no shortage of open source large language models, open source embedding models. There are also open source free to use vector stores and other different tools, frameworks, and software packages that could be integrated within that entire RAG system that are available online. And again, I would encourage everybody to check out the pointers that we included in the competition or the challenge description webpage.
Thank you very much. Yeah, I think that makes sense. Thank you for the explanation. There is the question, that's an interesting question. How does the design impact on possible queries from the user? Well, I don't understand the question really well, but I think Roman, as part of your presentation, you had mentioned that figure which explains how the RAG and the LLM are connected together. I think that's a good explanation for this. However, I will let you answer that question. And how does the design of the RAG system anticipate possible questions? That's a little complicated for me. But you did mention about pre-processing. You mentioned two things. One, the chunking strategy, and the other one is the pre-processing strategy. But yeah, so how do you answer this question? The design impact on possible queries and the anticipation of possible questions.
Okay, I think what the author of the question might be referring to here is the fact that it might actually be possible to introduce a template which any user query should adhere to. And this is actually one of the strategies that could be used to optimize the performance of RAG. So instead of free form type of questions which you can structure in any way, there could be a template indeed that would require to let's say provide some additional details or specifics that relate to the query that the user inputs. And this can actually facilitate the retrieval process, especially if you ask the user to include pointers to specific documents or specific subsections of the library that he or she might want the content to get retrieved from. Or that query template could also specify the type of action that the RAG application is meant to conduct. Should it be a summarization task? Should it be a bullet point guidelines task? But perhaps this can also be addressed through the introduction of a template for the model output. So I'm not sure if I managed to answer the question, but there are definitely ways in which the design of the RAG system can influence the types of queries that users make. And as a consequence, this would also lead to some anticipation in terms of what type of queries a user can provide, actually. But yeah, it's a good point. Using templates for queries and outputs might be a good solution for some of the use cases.
Interesting. That's truly interesting. Yeah, I never thought about that. Yeah, thank you so much. I have a question on baseline results. You did mention accuracy and the other metrics, quality, efficiency, and documentation. Those are the criteria, and the weightages are 60, 30, 10. Yeah, I think that's great. I want to ask about baseline results. Have we done some studies? Are there papers or are there papers in academics which explains the current situation of these numbers, metrics for open source models or even other types of models? What is the baseline results right now? What are the competitors? What are the participants trying to compete against here? I mean, is the field totally open, or are there numbers out there?
There are definitely some numbers and some rankings that can provide a point of reference. One of them would be the massive text embedding leaderboard on Hugging Space, the one that you saw a screenshot of at some point in the presentation. However, for the purposes of this challenge, our approach is slightly different, particularly because we're focusing on the retrieval part in isolation, so to say. So within the RAG system, you have the retrieval component and the generation component, and usually the rankings that we've seen online, at least, they rank RAG pipelines on the performance of the entire system, whereas we are trying to focus on the retrieval component specifically. So that's why the approach is a little bit custom made, and we're yet to see how effective it is. So please, participants, help us to find out.
Great. That's a great open area then. Thank you so much. I believe there are prospects for good papers. That's Jiaying right there. Thank you so much. That's where we close Q&A. Back to you, Jiaying.
Jiaying, you're muted.
All right, sorry for that. Thank you so much, Vishnu, for the Q&A session. And at this point, I would like to thank everyone for sparing your valuable time to join the session today. I would also like to express my sincere gratitude to our speakers, David and Roman, for their contributions. Please note that the challenge is now open for registration and participation. The link for registration is posted on the video wall. You can start working our solutions and submit the results on the portal. Several prizes, including certificates, are planned to be handed out the winners of the challenge. Details are on the challenge webpage, and we are also offering compute with GPUs that will be provided to challenge participants based on needs. We have more sessions in the future. Please check the AI for Good program page for details. You can also interact with us and other participants on the Challenge Slack channel. We look forward to your participation in the 2024 edition of ITU AI and Machine Learning Challenge. Thank you for joining and have a nice day.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.